Okay, so good morning guys. So yesterday we were seeing tabulation method and we saw two examples in it. So today we shall continue with it. Okay, so the first example we shall consider today is f of a, b, c, d. So which implies the function is a 4-variable function and the minterms corresponding to it are 0, 5, 7, 8, 9, 10, 11, 14 and 15. So with tabulation method, our first task is to group the minterms based on the number of ones in it. So with 0, we have 0 number of ones. In 5, we have 2 number of ones. 7 is 3, 8 is 1, 9 is 2, 10 is 2, 11 is 3, 14 is also 3 and 15 is 4. So for the step 1, the number of ones then the midterms and then the variables A, B, C and D. So with 0 number of ones, the midterm is also 0 and the equivalent binary is 0, 0, 0, 0. Next, with 1 number of ones, we have 8 alone. So 1, 0, 0, 0. Then with 2 number of ones, we have 5. So 0, 1, 0, 1. Then 9, 1, 0, 0, 1. Then 10, 1, 0, 1, 0. And then the 3 number of ones. So we have 7, 0, 1, 1, 1. Then 11, 1, 0, 1, 1. Then 14, 1, 1, 1, 0. And lastly, the 4 ones. So it is 15. And we have 1, 1, 1. So this is our first step. Next, we will start comparing the minterms in each of the groups. So the minterms and then the variables A, B, C and D. So here in this each of it we have only one thing. So 0, 8. So A variable changes, so we put a dash over there. Remaining we write as it is. Then comparing 8 with 5, 9 and 10. So with 5 we can see except for C all the variables changes, so we can't have that group. With 8, 9 except D others are same, so 1, 0, 0 and dash. Similarly with 8, 10 C alone changes and others are same, so 1, 0 dash 0. Next we have to compare this 5, 9 and 10 with 7, 11 and 14. So checking there 5, 7. So 5, 7. So 0, 1 dash 1. Then 5, 11 it is not possible and 5, 14 is not possible. So 5, 7 we have 0, 1 dash and 1. Then comparing 5 with 11, we cannot have the combination as more than two variables change value. Similarly 5 comma 14 also more than two variables change value. So next coming to 9 comma 7, again value changes. So 9 comma 11. So 9 comma 11 gives me 1 0 dash 1. Right? And 9 comma 14 is also not possible. Then 10 comma 7 not possible. 10 comma 11. So 1 0 1 dash. And with 10 comma 14 1 dash 1 0. And lastly we compare 7, 11 and 14 with 15. So 7 comma 15. So dash 1 1 1. 11 comma 15. 1 dash 1 1. And 14 comma 15. 1 1 1 dash. So the second step is over now. Then moving on to the third step. So with the third step, again we do the comparison between all these. So the midterms and the variables A, B, C and D. So here first comparing this group 0, 8 with these things. So here we are having dash in position A, however we don't have anything over here. So this term we are not including in any group. So I am denoting it with a tick mark over here just for identification. So next comparing this 8, 9 and 8, 10 with this 4 terms. So 8, 9 has a dash in the position of D. So that can be compared only with 10, 11. So comparing, you can see that 1, 0, only this C position value changes. So 8, 9, 10 and 11. So 1, 0, dash, dash. And then coming to 8, 10, we have the dash in C. So we have dash in these two values, that is 5, 7 and 9, 11. So checking with 5, 7, here all the three variables are changing. So we cannot have that possibility. So 8, 10 is compared with 9, 11. So we have 1, 0, dash, dash. So that group comparison is over. So here 8, 9 is also involved and 8, 10 is also involved. So we don't put any tick mark over there. Next, comparing this 5, 7, 9, 11, 10, 11 and 10, 14 with this group. So comparing over here. So here 5, 7 we have dash in C position. However, we don't have any in the next group also. So this is not getting involved in any of the group. So I am putting a tick mark over there. Then 9, 11 also has dash in C. So that cannot be grouped with this. However, this got grouped with the previous one. So I don't put any tick marks. Then with the last position. So here we can find the combination with this 11 and 14. So 10, 11 and 14, 15. So we have 1, B alone is changing value. So 1 dash 1 dash. Then comparing this 10, 14, it has dash in the second position. So this is compared with this one. So here also we can see 1 dash 1 is common. So 10, 14, 11, 15. So 1 dash 1 dash. And for first position we don't have anything with this 7, 15. So this also we give a tick mark. Okay, because this is not grouped with any of the terms. And then actually, if it is possible, we will go for further grouping in this. However, here we see the dash in position C and D, here it is in B and D. So we cannot go further. So these terms are considered as a prime implicant. Okay, because further grouping is not possible. So here, with respect to this min term, we have the expression AB bar. Here we have AC. Then this 7, 15 is BCD. Then 5, 7 is A bar BD. And this 0, 8 is B bar C bar D bar. Okay, so we are having 5 prime implicants. Now we need to write the prime implicant table. So the prime implicant table. So the terms and the group of terms. So we have with 0, 8 we had B bar C bar D bar. Then 5, 7. 5, 7 we had A bar BD, and 7, 15 we have BCD. Then 8, 9, 10, 11, and other is 10, 11, 14, 15. So the terms are AB bar and AC. AB bar and AC. Then the min terms. So we have 0, 5, 7, 8, 9, 10, 11, 14 and 15. So with this, we mark the X mark for the min terms that we have with the corresponding terms. Okay. So 0, 8. So I put the X mark in those terms alone. Next we have 5, 7. Then 7, 15. Then we have 8, 9, 10 and 11. Then we have 10, 11, 14 and 15. Okay. So next thing we see is single X mark, and the corresponding term we call it as the essential prime implicant. So I mark a star over there. So this is a essential prime implicant. Here again I have single X mark, so this is also a essential prime implicant. Then here I have single X mark, so this is also an essential prime implicant. And then here I have single tick mark, single X mark. So this is also an essential prime implicant. So all the other columns have 2 X marks in it. So now with these 4 terms, let us check whether all the min terms given in the problem are covered. So first is 0, 8, it is covered. Then 5, 7, it is covered. 8, 9, 10 and 11, it is covered. And 10, 11, 14, 15. So all the min terms are covered. So this is somewhat a redundant. So our expression will be F is equal to B bar C bar D bar plus A bar B D plus AB bar plus AC. So this is our expression. Okay. So if you are having some midterms in addition, sorry, some groups in addition, that corresponding term need not be always written. It is similar to what we do with K-map only. So here, if we are going to have the K-map for this, it is not always necessary to draw the K-map for this. This can be done only for your own checking, whether you got the correct answer or not. So here we have A, B, C and D. So 0, 5, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So this is what we are having. So with this, we have a quad of this which corresponds to AB bar. Then we have a quad over here. This corresponds to AC. Then here, for covering this particular one, you can form a pair over here or over here. However, this 5 does not have any other possible combination, so it is always wise to choose this term. So this gives me B, A bar B, A bar B, D, and this is with these two ones. So that corresponds to the term B bar, C bar, D bar. Okay. So there was actually the possibility of having this particular pair, but we didn't do it because that is going to be a redundant thing. That is the term you have got in this actually. So the tabulation method will give you all the possible combination of the terms. Okay. So this is our first example.
So for the second example, let us have f of w x y z is equal to, let the min terms be 1, 3, 5, 7, 9 and 15, and the don't cares be 4, 6, 12 and 13. So here, in some cases, near the summation symbol, they will give you the notation M to indicate that they are minterms and the D symbol for the don't cares. In some cases, they will straight away write the expression as f of w x comma z is summation of all these minterms, and D of w x y z is 4, 6, 12 and 13. Likewise, they will give. It is of just different notations. That's all. Okay. Now here, if you are given with don't cares, the procedure will be similar to what we do till the that is still finding the prime implicants. So you will be including all the terms given in the don't cares also while doing the grouping. Only when we go for the prime implicant table, we will leave the don't care terms from the column where we mark it. So we shall see it so that you will get a better understanding. So here to group. So with 1 we have one number of 1, 3 we have 2 number of 1, 5 we have 2 number of 1, 7 we have 3 number of 1, 9 we have 2 number of 1, 15 we have 4 number of 1, for 2 we have 1 number of 1, 6 is 2 number of 1, 12 is 2 number of 1 and 13 is 3 number of 1. I hope now you guys would be comfortable with the way I count the number of ones in this binary, because still always try to remember the 4 variable binary numbers as such. Okay, that would be helpful in doing the computations fast. Okay, va? Okay, so now with this, let us write the first step. So the number of ones, then the min terms, then the variables w, x, y and z. Okay, so the first step. So we don't have a zero number of ones here, so straight away one number of one. So first I write 1, so 0 0 0 1. Then we have 4, 0 1 0 0. Next we write the two number of ones group. So we have 3 0 0 1 1, then 5 0 1 0 1, then I have 6 0 1 1 0, then I have 9 1 0 0 1. Oh, we have 12. Yes, we have a 12. So for 12 we have 1 1 0 0. Then with, so always see to that you put a tick mark or some indication so that you don't miss any of the terms. Okay, sometimes we tend to miss it and thereby we get a wrong answer, so you just make a note of those. Now with three number of ones we have 7, so 0 1 1 1 and 13, so 1 1 0 1. Then we go with the four number of ones. So we have 15 1 1 1 1. Okay, so next we shall start comparing between the groups. So we will be having the min terms and the variables w, x, y and z. So comparing 1 with 3, we have 0 0 dash 1. Okay, then comparing 1 with 5, 0 dash 0 1. Then comparing 1 with 6, many variables change. Then 1 with 9 dash 0 0 1. And 1 with 12, many variables change, so we leave it. Then coming to 4, so 4 with 3, many variables change. Next we have 4 comma 5, so 0 1 0 dash. Then 4 with 6, 0 1 dash 0. Then 4 with 9, many variables change. And 4 with 12 dash 1 0 0. So there are so many possible pair in this. Next we shall move on to the next group, that is comparing 3 5 6 9 9 and 12 with 7 and 13. So 3 comma 7, so 3 comma 7 gives 0 dash 1 1. Then 3 comma 13, so many variables change over there, so that's not possible. Then 5 comma 7, so for 5 comma 7, 0 1 dash 1. 5 comma 13, so dash 1 0 1. Then 6 comma 7, so we have 0 1 1 dash. And then 6 comma 13, many variables change. Then 9 comma 7, that is not possible. Then 9 comma 13, so 9 comma 13, 1 dash 0 1. And then 12 comma 7, not possible. And 12 comma 13, 1 1 0 dash. So with this, the next group is over. Now we compare 7, 13 with 15. So 7 comma 15 will give me dash 1 1 1, and 13 comma 15 gives me 1 1 dash 1. Okay. So all the terms from the first step is grouped over here, I suppose. So we have 1, 4, 3, 5, 9, 6, 12, 7, 13, 15. Everything is over there. So next we shall go for the next grouping. So the step 3. The min terms and the variables. W, X, Y, and Z. So now all these set should be compared with everything in this one. It is a huge list as such. So that's why this tabulation method is time consuming for humans to do. But as this is a step-by-step procedure, it will be easier for the machine to do the computation. Okay, so let us compare. So here with 1 comma 3, we have dash in Y position, and we have dash over this 5 comma 7. That is the only possible combination. And yes, you can group it. Only the X variable changes. So 1, 3, 5, 7. So we have 0 dash dash 1, right? 0 0 dash 1, and this is 0 1 dash 1. So now we have 0 dash dash 1. Next we have 1 comma 5, which has dash in X position, and we have to compare it with 3 comma 7 and 9 comma 13. So comparing with 3 comma 7, we have 0 dash dash 1. Comparing with 9 comma 13, yes, there is a possibility. So 1 5 9 13. So that gives me dash dash 0 1. Okay. Next, comparing 1 comma 9. So 1 comma 9 has dash in W position, and here we have dash in 5 comma 13 in the W position. So 1 comma 9 and 5 comma 13. That gives us dash dash 0 1. Next, coming to 4 comma 5, we have dash in Z position. Here we have dash in 6 7 and 12 13. So let us see. So comparing 4 comma 5 with 6 comma 7, we have one variable change. So 4 comma 5 with 6 comma 7. Sorry, yes, 4 comma 5 with 6 comma 7. So 0 1 0 dash, here it is 0 1 1 dash. So 0 1 dash dash. Okay. Comparing 4 comma 5 with 12 comma 13, here it is 0 1 0 dash, here it is 1 1 0 dash. So that is also possible. So 4 5 12 13. So we have dash 1 0 dash. Okay. Next we have 4 comma 6, where the dash is in Y position. So we compare it with this 5 comma 7. So now 4 comma 6 is compared with this 5 comma 7. Next we have 4 comma 12, where the dash is in W position. That is to be compared with this 5 comma 13 is 5 comma 13. So comparing over there, we have just one variable changes. So 4 comma 12, 5 comma 13. So we have dash 1 0 dash. So one thing you can always check over is, you will be having, wherever you are having 2 dash, that term will be coming twice actually. Just the order will be jumbled up. So here with 1357, we have 1357. Here it is a different pair, 1537. The same way these will be coming twice. If we are moving ahead with another step comparing with this two position, we will be having that as 4 times or so we will get it actually. So we will see that. I don't know whether we are going to get that way in this problem because we are having so many quad over here. Let us check. So the first two group comparison is over. So next we have to compare this group 2 and 3 with these. So let us start the comparison. So here with 3 comma 7 we have dash in second position, so we don't have anything over here, so leave it. Then 5 comma 7 with 5 comma 7 with 13 comma 15, that is these two, 5 comma 7 with 13 comma 15. So we are going to have dash 1 dash 1. Then comparing 5 comma 13 with 7 comma 15. So 5 13 7 15. So dash 1 dash 1. Next comparing 6 comma 7, we don't have anything in the last position, so we can leave it. Then 9 comma 13 we have dash in second position, for that also we don't have anything in the last one. And then 12 comma 13 also we don't have anything in the last position. Okay, fine. So we don't have further group over here, and we can also see that all the groups are covered with this, that is all the minterms are covered. We have 1 3 1 5 1 9 4 5 4 6 4 12. Similar way 3 7 5 7 5 13 6 7 9 13 12 13 in the first group. Similar way we have 7 15 and 13 15 also. So here nothing is essential over there. So let us check whether there is any further possibility of simplifying this. So we shall go for the step 4. So here it is easier to compare because in this particular group you have the dash in first and third position. So that terms alone can be checked. So thankfully you don't have terms where first and third positions have a dash in the first group. So we don't have a step 4 now. Okay, so we are not having any step 4 over here. So here the minterms 1 3 5 7 corresponds to W bar Z. This corresponds to Y bar Z, and this one correspond to W bar X, and this one corresponds to X Y bar, and this corresponds to X Z. So next we shall write the prime implicant table. So the prime implicant table. The terms slash minterms. So we have, so here 1 3 5 7 is W bar Z. 1 3 5 7 is W bar Z. Then we have 1 5 9 13 Y bar Z. 1 5 9 13 is Y bar Z. Then we have 4 5 6 7 W bar X. 4 5 6 7 is W bar X. Then we have 4 5 12 13 XY bar. 4 5 12 13 XY bar. And lastly we have 5 7 13 15 XZ. 5 7 13 15 XZ. So I was saying while writing the prime implicant table alone, you will be having the difference. So here in this prime implicant table, you will be writing only the min terms, not the don't cares. So we have 1, 3, 5, 7, 9 and 15. You don't write the other terms, that is 4, 6, 12 and 13, because they are that of don't cares. Our aim is not to cover those in the minimized expression. Okay, va? So we will write only the min terms. So the remaining procedure is same only. So 1, 3, 5, 7, 1, 5, 9, 13. 13 is a don't care, so we don't have it. Then 4, 5, 6, 7. 4 is a don't care and 6 is also a don't care term. Then 4, 5, 12, 13. 4 is a don't care and 12, 13 are also don't cares. Then 5, 7, 13, 15. So 5, 7, 13 is a don't care. You have this 13. Right? So now checking for the single tick mark or single cross. So you have this as a essential prime implicant. So this is covering the terms 1, 3, 5 and 7. Then you have single tick mark in or single X mark in these two terms. So this is also a essential prime implicant. So 1, 5 is already covered. However, for 9 you need that group, and then for 15 you need this one. So the minimized expression for this is W bar Z plus Y bar Z plus X Z. Okay, this is your final expression. So if you are drawing K-map for that, so you will be having Wx, Yz, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So we have 1, 3, 5, 7, 9 and 15 as the min terms, and the don't cares are 4, 6, 12 and 13. So with respect to this, if we are forming the groups, you will be having this particular quad, so Y bar Z, then this particular quad. You may tend to take this particular quad, however that will not cover the min term 3, so we will go for this particular quad. So you have W bar Z and this particular quad to cover this 15, so that gives me XZ. Okay, okay, so we shall finish today's class here. However, I will give you an problem to practice. You just try it out. Okay, f of v, w, x, y and z. This is a 5 variable tabulation method, so you should have a lot of patience for it. So the question is 0, 1, 2, 8, 9, 15, 17, 21, 24, 25, 27 and 31. 0, 1, 2, 8, 9, 15, 17, 21, 24, 25, 27, 31. So please note down this problem and practice it. Okay. When coming for the next session, whenever we are able to continue with the portion, I will give the solution for this. Okay. So thank you guys.